Hello guys, this is Sapien from FEFO, and in this video tutorial we'll take a look at how to perform a steady-state thermal analysis of a simple plate in Ansys Workbench. So that will be my first tutorial on Ansys, so I hope everything will go smoothly, and my purpose is to show you the basics of this software that is used a lot in the industry. So here I just started Ansys Workbench, so I'm on the educational version, which is totally free, so you can download it if you're a student, for example, can download it for free, and I put the link on the description of this video. So let's start. So now you see you have several analysis systems, and if you want more you have to click on View All, and you have a view of all the type of analysis you can do in Ansys. Now I'm doing a thermal steady state, so I will simply drag and drop that in the main window, and the software will automatically create a system of different steps that are required to complete this analysis. So the first thing we'll take a look at is the engineering data, so we'll double click on that, and by default the structural steel is used, so we'll leave that like that for the moment, but we'll come back to it later. Second thing, very important, my analysis will be a 2D analysis. So if you are doing a 2D analysis, you have to go in properties of the geometry, and here you see you have analysis type 3D, so you have to go into 2D, and this is necessary to do that. If you don't do it and you hope that you will be able to do a 3D and then change to 2D later on, it's not possible, so don't miss this step, it's very important. Okay, now we will create the geometry, so double click on geometry and Ansys will open the design modeler. Okay, here's the design modeler, and in the design modeler we will do the sketch of the plate. So let's go in the sketching tab, in which you see that you have all the tools to draw the sketch, and here I will click on the look at the face to get it on this type of view. I like to display the grid, so I go in settings and display the grid. Okay. And now, before drawing, I want to be sure that the constraints are set to auto constraint. So you have to do that so it will snap on the right places when you draw your rectangle. And let's draw my rectangle. So you see it snaps here. Let's just draw a rectangle any size. And now I put some dimensions on it. So let's general. Okay, you just have to select the edge, and like that it will put some dimensions. Now to modify the dimensions, go here. So this one will be 1 meter and this one will be 2 meters. Okay, make a zoom. If you want to move a bit dimension, you can do that. Okay, now how do you go from a sketch to an actual geometry? So you can do that by going into concept, surfaces from sketch, like that, and here you have to select one edge of the boundary and click on apply to select all the sketch. And once you did that, you have to click on generate to create the surface, and now you have your part. So you see that in the walkthrough here, the surface body just appeared. Now you can hide the dimensions to leave on this plate. Now I just save that and I close the design modeler, and we are going back to the workbench. And now it's time to go inside the model. So when I click on model, the workbench will open Ansys Mechanical, and it will load automatically your geometry that you created. So the good thing about Ansys is that if you change your geometry and you update, you can get your new geometry directly in this. Now you have several steps that will do. You have your geometry here, surface body, coordinate system. We have to mesh that first, and then we have to assign the boundary conditions and to solve all that. So if you simply update the meshing, so it will create any type of meshing like that automatically almost, but you see that there's a little problem with this. I don't know if this is because of what, but the display is a bit, let me put it bigger in the screen like that, it would be better. So you see that it's not straight, or it's a bit strange. So in order to do it right, we have to do a face meshing. So we have to set up the face meshing, select the surface, apply, and once you did that, update, and you see now it's much better. Now it looks straight. Now if you want to change the number of elements on one face, we'll have to use the sizing. So we'll have to set a size, and you can either choose the surface or you can choose one of the edge. So here I will constrain the surface, apply, and let's define a size of 0.25 meter. Okay, be sure that you're in the meter unit. You can check that in the unit metric. Okay, let's update and see what it gives me. Well, it basically gives me the same thing, and this is due to something. This is because the behavior here is set to soft. So which means that you can set something, but if the software thinks that your size is too big, it will automatically decide to make it smaller. So here, if you set it too hard, it will simply obey the command that you gave, and it will create the right size. So now there's another thing. You see that there are some warnings here saying some local face element sizes are larger than the global maximum size. This calls bad quality elements. So we obviously don't want bad quality element. So in order to change that, we have to go in the mesh, sizing, and we have to select we have to turn off the automatic meshed base defeaturing. So if I update, oh no, it's not about that, it's that the curvature, you have to put it to adaptive. Okay, now you see the warning messages disappeared, and I get a perfect mesh as I want it. Now let's assign the boundary condition to this model. So let's click on the steady state thermal here, and you see that the bar here changes in function of where you're clicking. So now let's assign a temperature condition to this edge. So how do you apply to an edge? You have to change the selection filter here to edge, and you're not able to select the edge, apply, and set up a temperature. So we'll set temperature of 1. Okay, and on these faces here we'll apply a convection. Select, apply, and the film coefficient will be equal to 5, and the temperature is 1. So the film coefficient is the H coefficient. If you remember your steady state thermal courses, so the H coefficient is 5. Now there's another coefficient which is important, which is the convection coefficient, the conduction coefficient K inside the plate. So to change this coefficient, I have to look at the material, because this coefficient is linked to the material that has been defined. So if you click on surface body, you see that the material assigned is the structural steel. So what I want is to create a new material. So I click on new material, and it brings me to the engineering data sheet. So new, I will call new material. Could give it a better name, but anyway. And I have to drag and drop the isotropic thermal conductivity to this new material and set it to 1, the value that I want. Okay, now come back to the project, and you have to update your model. So you have to refresh, refresh the model and refresh the setup, and come back in your model. And now if you go in surface body, you see that the new material appears. So now I assign this new material here. Now I only assigned a convection and temperature to 2 of the sides, but in fact these 2 sides here, there's nothing assigned to it, and that's because they are actually perfectly insulated. So I could just assign a perfectly insulated boundary to this side, but it's useless to do that, because this is the default setting. If you don't set anything, it will automatically be perfectly insulated. So now that I've done that, I'm ready to solve this problem. So let's click on solve, and let's Ansys perform the mathematical solution with his algorithm. Now it's done. And if you go in solution information, you will be able to view the result under text format. So here everything seems okay. If you look, there have been 2 warning messages, 0 errors, so it's okay. Now let's look at the solution. So for that, go in thermal, click on temperature, and evaluate all results. And now there's a small problem, which is probably due, so I have 1 everywhere, and this is probably due, oh yeah, it's due to the convection. Actually I made a mistake, it's an ambient temperature of 0, not of 1. So if the ambient temperature is the same, then the temperature here, there's no point. So I change again, let's solve again. Okay, now you see that I have a beautiful temperature distribution, which is much better. So I have 1, so you can use the probe tool, temperature, you can use the where is it, temperature, oh here, probe, and you see that you can obtain a value at all the points of your model. So when I go here, the red value means it's 1, and on this side I have gradients of temperature, and on this side I have 0. Now, yep, that's it. So if you click, you will put some small probes like that on your model. If you want to change the color, or if you want to extend, you can drag and drop like that very conveniently the different colors. You can, if you double click on the color, you'll be able to change the color. And if you want to take a capture you can go image to file, and then automatically make a screenshot and save it on your computer. So that's it for this first tutorial. Thank you very much for watching. If you like these video tutorials, please check my blog feforall.com. I have a lot more interesting knowledge, tutorials and articles about not only FEA but also mechanical stuff, and my purpose is really to teach the basics of FEA and that engineers start to do it correctly. So if you like it, please join my blog, my newsletter, and you can also help me and share all that with your friends if you like it. Thank you very much, and see you soon on the blog.